In this video, we're going to look at a complete HVAC control system program developed in structured text. This program combines multiple control strategies into one unified application. Instead of separating each function into different programs, everything is centralized to simulate a real industrial controller. The program is divided into several main sections: PID control with EV management, compressor alarm management, daylight saving time handling, operating hours tracking, fan management, and finally a common control layer that connects everything together. Each section plays a specific role in the overall system behavior. We start with the part responsible for precise cooling regulation. Instead of using simple on-off control, a PID controller is used to continuously adjust the cooling capacity. The PID output is then used to control the electronic expansion valve. So the logic is simple: temperature, then PID, then valve position. To ensure reliability, safety mechanisms are included. If the PID encounters an issue, the system keeps the last valid valve position, and communication and alarm checks make sure the valve only operates under safe conditions. This approach makes the system more stable and closer to real industrial refrigeration control. Next, we have the compressor safety section. This part monitors critical conditions, such as emergency stop and pressure faults. If any issue is detected, the system immediately stops the cooling process. This means safety always has higher priority than control. After that, we integrate a time-based adjustment system using daylight saving. Depending on the region, the system detects whether it is summer or winter time and can adjust the temperature set point accordingly. This is useful for energy optimization in real applications. Then, we have the operating hours tracking. This section measures how long the system has been running, which is important for maintenance scheduling, system monitoring, and equipment lifetime tracking. Every time the compressor runs, the operating hours increase, and the value is stored to prevent data loss after a power cycle. Next is the fan management section. The fan operation is controlled based on the cooling demand. When cooling is active, the fan runs, and when cooling stops, the fan stops. Even though this example is simple, it can be extended to support more advanced configurations. Finally, we have the common control layer. This acts as the central coordination point, defining the cooling demand, managing outputs, and handling manual overrides. It works as the brain that connects all sections together. In terms of execution, the program starts by updating the daylight saving status to match the current season. It then evaluates the thermostat logic to decide if cooling is needed, while ensuring no alarms are active. The compressor alarm management then verifies all safety conditions, stopping the system immediately if a fault is detected. Once the system is safe, the PID controller regulates the cooling by adjusting the valve position. The fan management follows the cooling demand, and finally, the operating hours are updated to keep track of system runtime.